So in this question, you allow an object to fall freely from a cliff. For part A, you're supposed to find the speed at the end of 4 seconds. Part B, how far did it fall during that time? And part C, you are looking at a unique question which is looking at the distance that the object traveled during the third second of its motion. Okay, now this question deals with something called vertical motion. During vertical motion, objects can either move up or they can also fall down. Imagine you have an object, a ball. If you throw it upwards, it will move up, and then at a certain point it will stop, and then it will start to move down. Now, since we are dealing with quantities like displacement, velocity, and acceleration, which are vector quantities, these vector quantities are sign sensitive or direction sensitive. So the direction of the vector is important to us. And since in vertical motion we have either upward or downward motion, we need to assign one direction to be positive. For this particular question, I've chosen upwards to be positive and downwards to be negative. The choice is entirely up to you, but for this particular question, I've chosen this notation. And you can also flip it around. In other words, you can choose downwards as positive and upwards as negative. Now, one other issue that usually students have when encountering this kind of questions is you do not know which equation you have to use. Now, the equations we have of interest will be 1, v equals to u plus at, 2, s equals to ut plus half at squared, and number 3, v squared equals to u squared plus 2as. Now, what you have to understand, the reason I'm using these 3 sets or 3 equations to solve this particular problem is that for this situation, when your object is falling downwards, the acceleration of the object is constant. And the value of the acceleration is the gravitational constant, which has a value of 9.8 meters per second downwards. Now, why am I assigning the direction down? Is because acceleration is a vector. So gravitational acceleration is also a vector. Any vector quantity must have a magnitude and direction. Okay, let us look at part A of the question. Now, in part A, we are asked to find what is the speed of the object at a time of 4 seconds. Now, obviously, if you looked at the previous equations, those are vector equations. So v is velocity. Okay, so how do you get the speed? You have to remember that speed is actually the magnitude of velocity. So in other words, just the value of the number of the velocity. Now, so how do you solve this question? So obviously, since we're looking for the magnitude of the velocity, we need to find v. What information is provided to us? Now, let's assume the object starts from rest. So in other words, the initial velocity is 0. What this means is at time equal to 0, or at the instant the object was released, it was not moving. Okay, at that particular instant, the object was released. What we also know is that because it's falling freely under the influence of gravity, the value of A is 9.8 meters per second downwards. And what else do we have? We also have the value of time. this time corresponds to this particular value of v. So in other words, I'm calculating for the value of v at a time of 4 seconds. Now, if you look at this 4 parameters that we have, v we have to calculate, u we assume is 0, it starts from rest, a is the gravitational acceleration, t is 4 seconds. We don't need to find the value of s. And if you look at the 3 equations in the previous slide, the only equation that helps us solve this problem is this particular equation, v equals to u plus at. Okay, now let us substitute in the values. V is something that we need to calculate. U is of course 0. Let me just change this color here, make it black. So u is 0 plus, now here for the value of a, I have the magnitude and the direction. Notice that the a is acceleration. Acceleration is a vector quantity, so it must have a magnitude and a direction. So how do we take into account this direction down? If you have looked at our assumption, or my assumption earlier, I'm taking downwards as negative. So what it means is, when I substitute the value of 9.80 into the equation, I must assign a minus sign. This minus sign is because the direction of the gravitational acceleration is downwards, and I'm taking any vector downwards to be negative. Then what I have to do is put in a value of 4.00. So if you plug in these values into the calculator, you'll get a minus 39.2. Units is in meters per second. Now, how do you explain this minus sign? Now, this minus sign, if you look at our notation over here, we are taking vectors upwards as positive, vectors downwards as negative. So if we end up with a minus sign, it just means that the velocity is 39.2 meters per second downwards. It makes sense because your object is actually falling down, so the direction of motion should be down. But since we are only interested in the speed, we just take the value of the velocity, which is 39.2. Now let us have a look at part B. Now in part B, we are looking for how far did it fall during that time. So how far refers to distance or displacement. Now if you look at the equations, the 3 equations for kinematics, s is displacement, not distance. But the thing is, your object is falling down. So it's falling down. So it's just moving in one direction only. And because of that, your distance and displacement will have same value. Now let us look at what information this question has given to us. What we know is that it starts from rest. A is still 9.80 downwards. I'm just writing down. I'm ignoring the units, but it's okay because it's just intermediate steps. What else we're given? We are given t is 4.00. And we have, of course, we need to find what is the value of s. Now the only equation that will help you solve this problem is this particular equation. S equals to ut plus half at squared. Let us substitute the values. U is 0, t is 4, half. Okay, now a is 9.8 meters per second downwards. So what you have to understand is, according to our notation, vectors that are downwards must be given the minus sign. So when you plug in this value of 9.8, we must attach the minus sign to the front. then of course t squared. Again, if you plug these values into your calculator, you'll get a minus 78.4 meters. The minus sign here just indicates that the displacement is downwards, which makes sense because your object is falling from a cliff, so it's moving downwards. But since you're only interested with the distance, we just give 78.4 as our answer. Part C. How far does it fall during the third second of its motion? Now, to make it a little bit clear, what you have to understand is what is meant by the term third second of its motion. Now, what you have to know is that from t equals to 0, from t0 to t1, this is considered to be the first second. Oh, I shouldn't have written it like this. It should be second. Okay, so from t1 to t2, this will be the second. And from t2 to t3, this will be your third second. So you're looking for this value, how far it falls during the third second. So what you have to do is your answer will just be your displacement at t equals to 3 minus the displacement at t equals to 2. T equals to 2. What it means is you're looking for how far it fell from t2 to t equals to 3. So let us analyze this situation with a simple diagram. Now let's assume it starts from here, and during or after t equals to 2 seconds, it's at this particular point. So this vector represents the displacement vector. The displacement vector at t equals to 2 seconds. And let us assume at 3 seconds, the object is over here. So this red arrow represents the displacement vector at t equals to 3.0 seconds. So this is where the object is at t equals to 3.0 seconds. So what we are looking for is this particular distance. So this, I will just call it S, and let us calculate S. So S will be of course equal to just the value of the displacement at t equals to 3 seconds. I'm putting an absolute value sign just to indicate it's the value, minus from it the magnitude. The magnitude of displacement at t equals to 2.0. So what I'll do first is I'll calculate the displacement at t equals to 3 seconds. And in this situation, you will see that you will have to use the equation s equals to ut plus half at squared. U is 0, so you just put in half minus 9.8 times 3 squared, and that will give you a value of negative 44.1 meters. Again, the minus sign just indicates that it's downwards. Then you should calculate what is S at t equals to 2. Same formula, but different value of time. And this will give you minus 19.6 meters. Again, the minus sign just indicates it's down. So to find the value of S, all you have to do is take the values and subtract them.